should you have in, that would allow you to be successful in that. And so at HP, we were focused, and I think a lot of companies, whether you're designing a device for personal system use, or whether you're designing, something that's going to be used in a commercial environment, you have all those different aspects of it that have to play well together. The hardware needs to be able to meet certain requirements. The electrical has to meet certain requirements. The software has to do certain things. And is even more complicated now than it's ever been when you think about all the telemetry and the data aspect of what people are trying to do with what we're selling. So when you think about you're designing a motherboard for a notebook, but now you've got to include all these sensors into that so that you can collect more user data, and you can, get that telemetry, and you can automate some of what maybe has been done for years, through people calling in or looking at failure data and things like that. So I think it just becomes so important when you think about the teams working together. And so, as I mentioned at HP, there were disciplines that all participated on what was called a system team. You had the electrical, the mechanical, hardware, thermals, software, data, quality, manufacturing, all of those folks typically participate in the design. And there are a lot of constraints in everyone's categories. And so being able to work as a team and understanding all the constraints, based on financials, based on schedules, and being able to design tests and, checkpoints, I guess, in those processes, so that you know whether you're on track for ultimately meeting, the goals of what that product needs to be. So if you think about coursework that can help you in those areas, you can't neglect the financial aspect of it. You can't neglect the communication aspect. The software, the user experience, that's another one that I think has become so much more important in terms of how the users actually, what they do with whatever it is that you're designing, and how are you going to collect data on that, to understand if it's working the way it is, and how are you going to test it, and how are you going to accelerate that testing, because maybe you've only got 6 months to bring it to market, maybe you've only got 5 years, but it's something that somebody's going to use, or is going to be, have a usable life of 5 or 10 years. So how do you make sure that you're testing it? So as a computer engineer, you really have to think about that system and the environment that it's in, and what you need to do with it, and how do you test, and how do you verify, how do you manufacture it successfully, how do you validate things as early as you can in that manufacturing process, so that it's not just a test at the end of the line. So really thinking about all those aspects and coming together as a team, I think, is what allows you to be most successful as a computer engineer. So maybe, I don't know, Colin, if there's questions or other areas that you'd want me to cover.
I think if anybody has questions, we can open it up. I think specifically, if there's not questions, I guess I can come up with questions too. Is there any questions out there before I dig in? Just want to give you guys fair chance. All right, well, I'm not hearing any. So if y'all have any questions as we're kind of just talking, just please feel free to speak up. And I guess some questions I have, as far as computer engineering is concerned, and I guess going from degree to the actual field, what percentage of the information do you learn in school versus, where's the learning gap between where it comes in from school going into work?
It's a great question. And, I would say that, maybe there are statistics on this, and what I'm going to give you is sort of my Carol view, okay? There were courses that I took that were very applicable, that I felt like helped me, okay? And I mentioned, I worked in quality, so we worked a lot with data, a lot. And so one was like engineering statistics, okay? That was coursework that I felt like applied in a lot of cases because we were looking at performance and we were looking at warranty cost. So I think another piece was the engineering economics, the financials of decisions that you make, was another area that I felt, was applicable. There were areas in thermals that we spent a lot of time on that, again, being able to understand how thermals are measured and what that means and how that heat transfer works and everything. So I think there were aspects of a lot of those that applied to what I was doing. I mean, clearly, if you're a mechanical engineer and you're designing a system, I believe that so much of your coursework is going to apply, into that job. Electrical engineering, all that circuit design and making sure that, the way you're rating components that you select for your design are correct. So I do think, it's that basic engineering of problem solving that you learn in your coursework that applies when you get out. It may not be exactly the same problem, but how you work that engineering issue, how you solve those problems, how you test and evaluate and retest and evaluate, and experiment. I think all of that is what gets covered in, your basic coursework. So I would say certainly you'll see that, I think, as you get into your career. And then, I guess there's other stuff that you may, I had to take for engineering management, I had to take some straight business classes, accounting and things like that. I don't know, I didn't use that specifically in my role as an engineering manager, but I certainly used it in understanding the financials of the company, being able to look at a balance sheet, being able to understand if the company was making any money. It's nice to work for a company that makes money. And understanding, the business of shareholders, and that, when you're making cost trade-offs, it's not just about the design cost, because you can spend lots of money on a design, but your commitment to shareholders is that you're going to make a profit, unless you're working for a nonprofit, I guess. So I think in that respect, that's important as well. So I would say all of that is going to apply, and how you bring that judgment into making your decisions.
All right, well, thanks. I think that pretty much sums up my question. I believe there's a because that's a question, even though I'm not even in computer engineering, I'm just plainly electrical, but I think that's good advice across the board, just because I kind of look at that and say, hey, as
You
an
have to
engineer.
understand the business.
Mhm.
You have to
Yeah.
understand the business. You have to understand your customers and who you're designing for, whether it's a circuit, on a motherboard, and your customers may be internal customers. It may not be the person that ultimately uses the product, or it may be. But, somebody's got to manufacture that product as well. And so you have to be able to design systems that people can manufacture. So, I think understanding the engineering decisions of a manufacturing process is, great background as well.
Mhm. I think there's a question in the chat as well, if you want to take a peek over there.
Because it says, how the industry has changed and improved over the past decades. There are many new technology and breakthroughs in the industry. What did you do at HP to keep up with the rest of the industry? So there were folks that were working on the products that needed to be delivered now, if you want to call it that. We had a roadmap, and there were system teams and development organizations that had to deliver to that roadmap, specifically because they had commitments to customers. And in the environment that I was in with consumer, Best Buy, for example, if you've got shelf space in Best Buy, you better deliver that product, in the time that you say you're going to deliver it and the cost that you're going to deliver it in order to get that shelf space. Okay. So understanding that, but we also had groups that were typically that were more focused on the future and technology and strategy. And how do we bring those new technologies into the next design? And you really have to get in front of that, because when you think about how long it takes a design to bring it, to manufacturing and bring it out to the market, you have to be ready for that. So at HP, typically those technologies were driven by people like Intel and other people, NVIDIA and some of the chip suppliers. So depending on what they were capable of doing, the processor, obviously being the main part of the system, the whole, the brain of it, or people like Microsoft, HP had agreements with Microsoft. And so oftentimes, you have to know what those technologies are that are coming. So anytime that the Windows environment was going to change, for example, we had to have people that were working on those next generation technologies so that they could understand the processes that were used and how to bring those new technologies in. So typically separate group from those delivering the here and now product, but being able to understand how to incorporate that in was really how they brought those technologies through. And then you had the people that were looking at technologies that were 5 and 10 years out. People have been looking at 5G, right, for long before it goes into any products. And how do you bring those technologies? How do you test for that? How are the customers going to use it? And again, that was typically a separate group so that they could focus in that area as opposed to the ones that had to deliver the product. Does that help answer that question? Song Tran, I think, asked that. Okay, great. Other questions?
Oh, could I ask a question?
Sure. David.
Yep. So I've heard from, I guess, some of my friends who already graduated that a lot of CPEs would end up primarily just focusing on one aspect, either hardware or software. And I see HP, how you just said that they do all of it. There's some people do the hardware, some people do the software. Is there some way that you can do both of it, or some way you can do both hardware and the software through your career?
That's a great question, and I think the answer to that is yes. It probably depends on how the companies are structured and how they structure their development processes. But I do think it's a good question in that there's so much crossover now between all these areas that being able to bring that view of electrical and hardware and software, together, I think that it would benefit, companies. understanding it. Now, maybe your primary responsibility is to deliver on the mechanical aspect of the system or something. But again, being able to understand those other areas and that helps you to improve what you're delivering, I think is good. So, I just from my experience at HP, what I was talking through was how their system teams are definitely set up. But I think if we were to have you talk to somebody from HP that's part of that system team, they're going to tell you, oh, we cross over all the time, in terms of giving feedback back and forth, understanding the challenges. But you also have to depend on the people that have the expertise in that area to deliver on what they're supposed to deliver. It's kind of that you can't do everybody's job. I hope that helps, David.
Yeah. I mean, that makes sense.
It's a great question, I think, to ask when you're interviewing with companies, though. How do they draw the lines of responsibility? And I'll give you an example that's not as really applicable to the computer engineering, but I was in a GBU global product group, and we had folks that were in the regions. And the regions were responsible for delivering products within each of their regions: North America, Asia Pacific, whatever, EMEA. And yet we're in a global group that's supposed to help represent those three areas as well. So we had to understand the delivery models for all those different regions, because we had to take that into account in what we were doing. So, similar to when you think about computer engineering, you have to understand the hardware, the electrical, the software, all those aspects of it to be able to deliver. So you still get exposure to it, is my answer.
All right, do we have any more questions? I'll give some time just in case, because I know what happened last time.
Oh, if it's all right, I'd like to ask another question.
It's perfectly all right. Go for it.
I guess this is kind of reiterating a little bit what Colin said, but so when like the gap or like the things you learn in college versus when it comes to like the real world, is it more like you talked about how learning how to like problem solve while you're in college? So is that like the primary focus? It's not as much like the content what you learn, like you get exposure to the content, but that's not like I guess the main takeaway from college when you start like applying it to the real world. It's just more like, okay, how to like break down problems and how to.
So I'm sorry, I didn't mean to, certainly that's important, but no, in specific areas, when you think about mechanical design, when you think about electrical design, there are aspects of design that have to be taken into account that you're learning in your coursework. And so I think definitely that's going to be applicable. And how you calculate. So, if somebody says to you, well, in this circuit, I need, your max power is going to be 3 watts, you can't, or whatever that guideline is, and you have to be able to design to that. So I think in your coursework, you're learning how to measure that, how to work those basic requirements into a design. So I would say, that aspect of it in specific engineering definitely is going to be something that you're going to use in your job.
Oh, okay. So it's just like in like college, it would give you like kind of like the introduction on how to like do the basic things. And then once you go to like the job, then it becomes more like detailed and more specific on like, I guess, expanding what you already know.
Yeah. And the other thing about your course, it teaches you to think. And so you are problem solving, and you're learning how to think, and you're learning how to use the tools that you have available to you. And in those specific disciplines, there's different tools that are available and that are critical, and some that are not as critical. And I think those are all things that you're learning, that you're going to apply, that will make you a good engineer working in a technology environment. You know, whether it's the material, whether it's the, you know, electrical characteristics, whether it's the mechanical characteristics, you know, how to take those and understand what those numbers mean so that you can bring it into a design. You know, I don't, it's interesting because you talk to some people maybe that are out there that, and we had a focused college grad program at HP. And I had the woman that was running the program that had the 5 college grads worked for me. And they developed a lot of interface between those grads and mentors and people at the company to kind of, you know, help that. And I think some of like, yeah, I don't feel like I'm quite using, you know, my degree, but I think as you get into it, again, it depends on what job you're in. It's hard to get hired as, let's say, you know, you want to be the mechanical design engineer for some system. It might be hard to get hired as a new college grad directly into that mechanical design, you know, running the mechanical design team. And so working with people who are the mechanical designers and learning from them and applying your education, and then ultimately, you know, moving into that position. So that may be what people tell you, well, I'm not exactly doing, you know, what I thought I would be doing, but you know, the first few years, I think you really are learning how all that comes together. And it's been a long time since I've been a new engineer, but I think that's what I heard from you know, some of the folks that came in to HP.
Okay, that makes sense. Yeah, thank you.
Mm-hmm.
All right. Well, thank you, Carol, very much for coming and presenting for us. And I guess I'll give an opportunity for any more questions, if there are any. And if not, we can move on.
Okay. All right.
Awkward silence.
Just making sure, no questions.
Yeah.
Okay. Thanks, Colin. Thank you.
All right.
Bye.
Thank you, Carol. All right. Our next presenter is one of our students and a fellow IEEE officer, Dana Dailey. And
Yes.
also presenting with her is Alex Howell. They are IEEE educational outreach and marketing. So thank you guys for joining us. And what do y'all have for us today?
Yes, Colin, thank you. Well, today, as Colin said, sorry, my name is Dana Dailey. You might know me as the IEEE Educational Outreach Officer, or you might know me as your TA from ECE 2100. And joined with me today, I have my friend and fellow computer engineering major, Alex Howell. Say hi, Alex.
Hello. I'm sure y'all seen me on the Discord if you're on there. I'm the one that's always adding everyone on the events and stuff.
And if you're not an IEEE, we have the reason, or we have the thing for you.
Yeah. So today we wanted to give y'all a little bit of student perspective on the major. Alex and I are both senior computer engineering majors, and we wanted to talk to you about our experience, why we chose computer engineering as a major to begin with, and then also we wanted to mention a little bit on what courses we find important for obtaining internships on both like the software side of things and on the hardware side of things. And then if we have time, also talk about our personal experiences in the previous internships that we've held. So to start off, we're going to talk about why we chose this major. So I'll go first and then Alex will go. I know we have similar-ish stories. But basically, when I was in high school, I took a computer science class for 2 years, and I really enjoyed it. We wrote in Java. Well, yeah, we wrote in language Java, and we just did a lot of object-oriented stuff and, just basic learning of a language, and I really enjoyed it. I thought it was a lot of fun. I thought programming was super cool. But I had also always really been interested in engineering, looking at how things worked. And I also was into like computer building for a little bit when I was in like 8th grade. Super interested in that. And so that's what kind of sparks my interest to look into, electrical engineering, computer science, computer engineering, those sort of majors. And I settled on computer engineering because it was a good mixture between all of the things that I enjoyed. So looking into, how things worked, that's more of like the electrical engineering side, and then programming, that's more of the computer science side. And the good balance between those two, the good mixture, is computer engineering. So that's the main reason why I chose it. And if you want to go next, Alex.
Sure. So similar thing, high school. I started off with engineering, taking the intro to engineering design, principles of engineering, and then another higher level engineering for the high school. I thought they were really interesting, designing stuff, figuring stuff out was always cool. And then I also ended up taking Java in 2 different courses there too. And I really started to like programming, especially in one of them. I taught myself how it works, so I got a really good understanding, which actually helped it going into like MATLAB and figuring that out, because everything is it's basically the same thing, just different syntax. But with the way things are going too, everything's has to do with computers. I would say that would have, going to computer engineering would be a good investment in going into. So I would just have to grow with the industry. So, and of course we always use computers. Computers are cool. Just say, oh, I made a computer, or I designed a part. I always thought that would be cool too.
So yeah, those are our reasons for choosing this major. So if you have a similar, experience or similar interests, then maybe you thinking about computer engineering, or maybe you should think about computer engineering. But yeah, okay. So next we wanted to go into the courses that we think are like the most important for obtaining internships in like the fields that computer engineers can go into. So I'm just gonna share my screen really quickly. Yes, okay, not that. That's a Gantt chart.
Okay.
Yeah, go ahead.
So this is the list of what we thought would be the more important courses for computer engineers. Circuits 1 and 2, are your good starting point. C programming is a big one, because that's like first real language you learn in this course. MATLAB doesn't count for an actual language. And then that shows you basically like what you're getting into for later, because this class is required for you to take before you take C++, the computer science courses. So you learn C before you learn C++. So if you're doing good in C, you'll do good in C++. Plus, if you aren't doing that good, it's okay. C++ is a lot nicer than C. So there's still a little wiggle room there, but C is an important class. DLD and microprocessors are kind of hand in hand. They go over the same thing. It's just micro P, you go through the basic programming, like sorry, I'm tired. You go through programming stuff with assembly. And it's a good way to see how very low level programming works, because it's not just like, oh, I can call this number, num, and then I can add it to another variable I have, right? So you actually have to control bits. You have to very closely see how it all works. And, you know, you can do stuff like bit shifting, you can and or, you know, XOR all the bits and stuff. It's not like normal programming, and it's really cool to see how it works at such a low level. So it's also a road you can probably go down in the future too. If you really like that, you can look into lower level stuff. Intro to programming is the C++ class with the computer science. Let's see, microprocessors is directly programming each aspect of the processor. It's pretty close to, yes, because basically you're using registers to do what you need to. So if you call like branches and stuff like that, it's, you know, it puts on the stack. So it's very close to like programming the processor. It's like basically you would be doing what C++ does for you. So if you were to write in like, you add 3 numbers, 1, 2, and 3, you can do that in one line in C, but then if you were to go into assembly, it would be the same idea, but you would just have to do it like one number at a time. Or I guess it's very close, basically. Just take out all the prettiness of the computer languages you would know. And Introduction to Programming is your first C++ course. Yeah, Micro P was one of my favorite classes. It still is one of my favorites. Intro to Programming, C++ course. It's basically another run through like C. You just learn it, different syntaxes. Data structures is a big one for computer engineering because this is the basis of what software engineering kind of looks for. Because this is where you get into further, you know, object-oriented programming. That's where you would start. And then you would get into bigger stuff like linked lists. Then if you can remember a few too, there's linked lists.
Queues,
There you go, queues,
trees.
stacks, binary trees, all that good stuff with pointers, because pointers are so important. So learning that is very important to probably going into your future. Digital electronics is basically a step up from DLD because you designed AND gates, OR gates, and all the other gates with a kind of transistor called a MOSFET. And you could probably use it to go into something like IC design. That's what they would be used for. During the class, you'll get CMOS chips and you know exactly what's in them because you can design CMOSs with the MOSFETs you get. And then Discrete Math is a math course that is taken by computer science majors also. It's a very good way to look at like logic. So it starts off with proofs and it goes into like sets and stuff. It basically just takes you through a whole process of how you can look at these problems. I know Dana said before it's been helpful in the stuff that she's seen. Like having known it in this or seen it in Discrete, it's helped her with her stuff too.
Yeah, I'd like to say that Discrete Math really gives you a mindset, or it helps you with the mindset you need for programming. Because I like to think, you know, being like a software engineer, you kind of have to have like a completely different approach to how you look at problems than like other problems that you would do in like math class or even in like circuits class. You have to approach them differently. And I think Discrete Math really helps you with that mindset. So it's an important course.
I guess it's kind of like where logic gates meets math, right?
Yeah,
The generic
kind of.
way to put it.
All right, so now we'll move on to our internship advice. So on this slide, I'll kind of explain the different kinds of internships that computer engineering majors typically hold, and then the emphasis on what classes you'll primarily need in order to, you know, do well in these internships or to maybe even obtain these internships. So first are the software-based internships. These are, of course, going to have a heavy emphasis on your computer science classes. So that would be like Intro to Programming and Data Structures. I would say if you're interested in going into software, a computer science minor might be something you want to look into because it enables you to take more computer science classes that you wouldn't take regularly in the computer engineering major, and you'll be able to receive some sort of well, you'll still receive credit for them, but I mean, you'll be able to receive something else in addition to your major. Receiving that minor, might be very appealing to you. And then important classes for software-based internships would be like computer architecture and your software engineering class that you'll take in your junior or senior year. And then of course the ones that Alex mentioned. So like the computer science classes, Intro to Programming, Data Structures, Microprocessors, DLD, Discrete Math. Those classes would be the most important for your software-based internships. And then for hardware-based internships, of course, it's going to be a heavier emphasis on ECE. So additional important classes to, circuits 2 or digital electronics or electronics would be advanced digital design, embedded systems, advanced microprocessors, and maybe even applied EM if you're looking into going into some sort of like PCB board design. EM can be very important for that. So those are some things to think about, in terms of classes when you're thinking about what kind of side of computer engineering you want to go into. But of course, some computer engineering internships will require both skills. And I know that the previous speaker, David, I think it was, asked a question about, using both software and hardware in your role. And it is absolutely possible. I know last semester at this event, actually, we had a different speaker who talked about how often he used both hardware and software aspects of his degree in his job and with his team. So it is definitely possible. There are some roles that will require both, but more commonly, computer engineering students normally kind of veer off one way or the other. So those are just some things to think about. And how are we doing on time, Colin?
I can give you guys a couple more minutes if you need it, but just a few.
Okay, well
There's
then.
One more thing before we get to questions. Just so y'all can keep in mind too, if you are doing computer engineering, you're one math class away from a math minor. And that's something that computer engineering can do that electrical can't, because they take numericals, which is a ECE class. We take discrete, which gets us closer.
Yep,
So keep that in mind.
To think about. But yeah, okay, so let's go ahead and open it up for questions since we're short on time. If anyone has any questions.
We've been through it all.
Yeah.
All the courses on the degree plan, we've been
Can I ask
there.
a question?
Yeah.
Yeah. Go ahead.
So when you're starting to like look for internships, and I know you guys say like some like based off what you want, right? Either like software or hardware. Like how do you recommend like showing that? So is it like you show like the projects that you did in class to like explain it? Because like how you can just write like skills and you're like, okay, I know C++, but like to show that you like demonstrated, do you like say like I did the school projects, or even for the ECE, do you like show some kind of projects you did from that class to show to like recruiters and stuff?
Absolutely. I'd say it is, if you're not putting your projects that you've done in school that are, impressive on resume, you need to be, because those are a great display of the skills that you know. And yeah, so absolutely, 100%.
Yeah, even like I don't know if,
And you can add projects that you've done on your own as well.
yeah, all these things help. Even like I don't know if y'all did it for 1331, but the Simon game, I had that on my resume for a while. I've talked to people in interviews about it. They're always curious to hear like, oh, you did the game. Oh, that's so cool. You know, because it all helps. If you want to focus on like software, you can put more software stuff. If you do a project yourself that you're proud of, throw it on there. It can't hurt. They'll ask you about it. You can tell them what you know, and they'll be like, "Oh wow, this guy's smart."
Yeah,
You know.
absolutely. I had the Simon game on my resume as well as the traffic light
Mm,
controller project from MicroP.
Mm-hmm.
And
You got a
you know, I
state
had a
machine for
DLD
that one.
project on my resume as well. So the state machine traffic light controller for that one.
Yeah.
So yes, you should be putting your projects on your resume. And so, like I said, you can put the ones that you've done yourself on there as well. So if like you made a Python Pong game, go ahead and put your Python Pong game on your resume. You can be like, hey, this was super cool. I made it in like 5 hours, but the recruiter might be impressed by that. They might just be impressed by the fact that you're interested enough in the you know, the language, or interested enough in programming that you do it in your free time, you know?
And I would suggest putting like under your skills and stuff these languages, even if you barely know it, or like you know it like to a basic amount, still put it on there because they'll see it. Because like I had basic Python on mine, and then I actually had someone like say, "Oh, you know Python." I'm like, "Yeah, sure, we can go with that." But
Yeah.
put as much as you can without lying. Like I know basic Python. My senior design project's in Python, so you know I have no problem going on there and putting it. You know, I can figure whatever out if they need me to. But you throw everything on there you can.
Yep.
All right. Well, thank you guys for coming out, and we really love to hear from you guys. I believe Dr. Chen is online, and I bet she's raring to go.
Yeah.
If y'all have any more questions for us, y'all can like
Yeah.
DMS after or later.
If you
Yeah.
have any questions, reach out to me. I'll send out my email if y'all haven't got it already. It's also on the RSVP form. You can also find any three of us on the Discord if y'all have any questions.
Yep.
Bye, guys.
All right, bye.
How you doing, Dr. Chen? It's good to see you.
Yeah, I'm good. It's always the most exciting week of the year.
Yeah,
I'm
no
so
kidding.
I'm so happy to talk to students during this Rising Week. And again, just claim that I'm actually the advisor for both the embedded systems as well as the computer engineering. So I'll give another talk on computer engineering on Thursday. And I try to make it kind of a little bit unbiased because it's literally, I'll talk about the advantage of one over the other a little bit to see what kind of trade you have, but I'll talk basically how common things that where it fits into your career goals and also your personality or skill set. And then after that, and if you come back for computer engineering talk, I'll talk probably a little bit overlapping because the career path is close enough, you can claim that there's a job open, you can actually apply from both positions, but also talk a little bit about the advantage over computer engineering in some aspects. All right, so let me share my screen. I usually talk not direct through the screen, but it's better just to have that there, especially when you actually are going to answer questions about the completing degree form.
Sounds good.
Everybody can see it?
Yes, ma'am.
Okay, great. Okay, so this is just a common slide coming from the department. And just in terms of my name is Yuhua Chen, and people sometimes call my Y Chen. And there are so many Chens and lots of J Chens. I'm the only Y Chen. Okay, so I'm fine if you find my first name hard to pronounce. I know students talk about it, but I'm the only Y Chen in the department. I'm the advisor for both computer embedded system as well as CPE, which is computer engineering. And for both students, all their degree plan forms coming to me first. And again, either they attend this advisory week, they know enough about the courses, or I actually email back and forth about the information. And sometimes I actually do face-to-face Zoom kind of sessions to let students know better. I want them to make their choice wisely. It's an informed choice instead of just fill out the forms at the end to find it's just not the career path you want to take. So that's something I will talk a little bit about today. All right, so here you see kind of different pictures. Honestly, computer embedded system is everywhere, except for the, say, Google servers and laptop and regular desktop computers. I don't even know if I have one at home. Everything else is embedded system. It goes to even now the refrigerator now. So microwave oven, that's common sense, but cars and well logging, we are the kind of city for oil and gas, and there's so many things that computer embedded system engineers can do, because you see this little picture right there, right? So when they actually oil and gas, when search for the oil, they put little things into this really, really long tube. And on there are different type of sensors, electronic boards, and the microprocessors, and the processor is going to process all the sensor data just on that run. And the operational cost, can you guess how much it actually run the things down and up once? Over $1 million one time. So that really puts a pressure to, say, electrical engineer or embedded designers, because if they have a bug, you go down and up, it didn't work. If the data is not accumulated, not stored properly, then not processed. Once they get up, $1 million long, just in that one run. Not to say that they have to shift the boards back to the headquarters and the debug by the engineers. So one thing I want to say that the number one trait either going into computer embedded engineering or computer engineering major is the responsibility. There are so many bugs around, and again, I'm not sure how many of you actually coming directly from computer science background, but also I actually acquired a computer science degree on the side, but electrical or computer engineering is still my core. The difference between a so-called desktop like computer program versus embedded is that we really carry so much responsibility. One of my friends actually joined many years ago to with Microsoft, and she was working with Microsoft Office. And she just told me by the time the release day, can you guess how many bugs they have in that Word? That's why you see Service Pack 1 and 2 and 3, because they release the product with bugs and fix that later. Well, they reason that the Word is not going to kill people, right? So you live up with the bug one day or two, but not anymore, even for some of these desktop programs, because they actually control lots of devices on the field with the computing technique. So the field carries more and more responsibilities. And the one thing that actually 1 year, the Boeing plane really crashed, and I was really sad that year. And one of the things I have students do is to cross-examine their code and telling them if you have a bug in the first course, you have to announce it. You have to disclose that before the product gets released. The second one, you think that you can kind of cut corners and say, okay, that's just one little bug. Let me fix that after the product release. Guess what? Once they call the sign off, any single change has to go through, say, more than 10 signatures, all the way to the company's chain, up to maybe vice president at that range. That means if you find something, you better fix that now. And this requires two things. First, you have to be really, really dedicated. And basically, as a designer, we almost really want to achieve these bug-free states. I know it's really hard to achieve, but in terms of medical devices or cars or planes, there's so many things that could go wrong, and we're responsible for that. So that's number one I want the students to have. The second one is, of course, they have to hold, the integrity is number two. That means you have to be really, really honest to other people and to yourself. And so basically, if you go to those programs, I don't want any student to cut corners. Like people coming to my class, they have to touch up every single signal on the FPGA inside. I'll talk a little bit about my course later, but my FPGA does not lie. There's no package you can install with software and you can run it and you don't even know it worked, right? But if I hand over one of my boards, is the FPGA board, I should. I don't know if it's here. No, I don't know if you can see it. Oh no, sorry. I have this future background, so it don't work. Anyway, so basically, if you get one of those FPGA boards, every single signal is not doing anything unless you tell it to do. So basically, students are doing the entire almost game system on my FPGA board, but they touch every single signal, not only for the level, but duration. If you get one signal, one cycle too long, it's wrong. It will show. So you need really those dedication to be in this field. So those are the things that I want to say up front, if you're suitable or not for this. And in terms of the job opportunities, there are so many job openings in these fields, and locally and globally. And locally, for example, HP is constantly recruiting students from our campus, and then Silicon Valley is hiring our graduates. And actually, one of my PhD grads, of course, doing a dissertation under me, is working for Apple, and he is the architect of Apple's neural network chip. And my other PhD student grad was working for Google now, and he's a software engineer. And more recently, I have another PhD grad who is going to join Intel really soon. So they're all competing against each other. And locally also, like our grads are getting the reputation because of rigorous training through the program. And you really cannot go wrong with the courses in computer embedded, as well as, of course, computer engineering, because every single course is really up to date. We constantly update those courses. So the company just love us. And we could have students who got hired during those sessions, during the last pandemic, it's not over yet, but say April or May last year, people hiring our grads in the program. So it's really impressive. And we are the energy city, so there are lots of energy jobs that we want those embedded systems skills, and also NASA. And I have a bunch of my former students working for NASA and their subcontractors, and very exciting. And well, before I move on to the courses, I want to say that please take one control course, because it's so important. It's so hard to pick once you get out of the school. Why? Because, well, you teach, say, embedded programming, you even teach chip designs, but what do you program for, right? And lots of times the embedded systems are used for controlling robots, controlling some of the manufacturing facilities, and those you have to implement the control laws inside those. It will be really hard if you never taken a control course and rely on someone else to tell you how to design these systems. So there will be, these are not required courses, but I'll talk about it, and there will be elective. It's highly recommended that you take one. So any questions? I know you're pretty excited, but please chip in and ask any questions before I move on. No? Okay.
Hey,
So
Dr. Chen, I
yeah,
believe
sure,
today
go.
was supposed to be the computer engineering presentation.
Oh, you mean today's computer engineering?
Mm-hmm.
Oh, I'm sorry.
Yeah.
All right. And this is, okay, let me see. I must have put it on my,
Sorry about that.
but the pre-heading part is similar, and actually courses I'm about to talk about is also similar to, but let me quickly grab my other slide. I'm so sorry.
It's all good.
Yeah, but they do share the common courses. And
Sneak
again, it's good.
preview for next Thursday, or for this Thursday.
And again, it's good that actually people listen to both sessions, because at least people who cannot show up on Thursday, at least hear a little bit, because I want them to think about which major is the best for them.
Mm-hmm.
Okay.
Yeah, wish we collectively would have caught that sooner, but I apologize.
I'm so sorry, but the beginning part, the responsibility and also the integrity, they all share the same trait because everything we do in both majors will go there. Let me unshare this. Share another one. Okay. Sorry, I haven't got a chance to update the date yet, but the content is about the same. Okay. And this speaks for both majors. And the computer engineering is the fast-growing field and discipline. And for a long time, it's kind of under EE, but now from this point on, it will be becoming a beast of its own, I would say. And CP major actually goes to kind of two branches. One is the hardware computer engineering, and the other is more like software engineering. Sometimes some schools will also call that computer engineering. And the strength for our school is more towards the hardware side, but not lacking the programming. We will say that programming skill is the must, even go to any of the computer engineering majors. Kind of similar also to the embedded as well. And I just want to show some of the prospects. Okay, before I do that, and again, this is blurry. This applies to both computer engineers and embedded engineers. And what they do, they actually have a freedom to move anywhere between the software and the hardware disciplines, or more and more, they actually have both because lots of programming are shrinking to smaller devices like robots and the drones, right? And people hire those computer engineers for almost everything. Computer manufacturers and like HP or Intel, they will hire computer engineers to do their chips. And lots of defense contractors around the area, like NASA, and also DoD has some contractors around this area. And there are lots of jobs in Colorado as well. So some people actually move over there. And then basically being a computer engineer and sometimes the embedded system engineer as well is that you can literally have your own startup. I have several of my former students had their own startups. One is already getting like public funding phase where they actually each one can chip in, say $100. Hopefully that $100 will become kind of a really large sum. But they were doing lots of good jobs and they actually constantly getting awards nationally. So computer engineers will get those advantages as well because they can innovate. So this is a really quick snapshot where the jobs are. And it was surprising because I was in charge of getting a new computer engineering PhD program into our department. And so that was the question coming from the provost's office asking me where jobs are, why does Texas need another computer engineering PhD program? So I went to the website, and this is from the US Bureau of Labor Statistics. And I was so surprised to look at this because everybody talking computer engineering jobs number one is of course California, right? But if you look at the color here, the dark green is the most dense job where the jobs are. And Texas, it has the same color as California and Washington State. So I was really, really surprised about that. That means even if you never want to move out of Texas, there are tons of jobs around Texas. So there are three major concentration areas like Houston, Austin, and Dallas. And there's some nearby small cities as well. But this really surprised me when I tried to answer the provost's question there. And so this was a snapshot. I went to, because the post office asked me to show where the jobs are. So I did a search on LinkedIn, and it was just kind of a snapshot during COVID-19 and during the scary part actually last year. Then if you look at the posting here, there are so many jobs in, say, Dallas, some in San Antonio, Austin, and Houston. So just name it. It went on pages and pages. And I just, after a little bit, okay, I think that's enough to show them. So that means really there are jobs around, even during COVID, because people are scared that they don't get jobs during that period. But if you really get the skills, don't worry, people want you. Okay, so those are the things. And again, this only Texas, and I just did a few searches, but there are jobs nationwide. And now it comes to our CPE flowchart. Of course, this one is different from the embedded, but thank you for reminding me to catch this right before. And for CPE, you have less choice to make, but we already made the most of the best choices for you. Because if you compare, should I go to CPE versus embedded? So I would say that if you really want to be on your own, almost create your own specialty beside embedded, you probably want to go to embedded systems because you have a variety of courses you can choose as electives. And for CPE, because there are state requirements and the computer skill requirement, so you take additional computer science courses compared to regular E students. So it leaves you less room for the electives. You need to choose 2 CP electives out of 3, then I believe you are able to choose another ECE elective with a lab. But everything else kind of already paved the way. And I think that's not a bad choice. And all these courses I'll tell you are good courses. You won't do wrong going to any of these. So any questions about the flow chart? Okay, no.
Yes, I do have a question.
Yeah, sure.
So for these CPE electives, they're specifically, if you're looking at the degree plan, they're specifically in the computers and embedded systems section?
You mean in the degree plan?
Yes.
Not this one, right? This one?
Yes.
Okay, sure.
Thank you.
Yeah, so we will talk about these 3 choices just a little bit. So before that, I just want to show what these are. And again, the other thing I want to say is that the microprocessor was previously called 4436. So that's why it was a co-requisite for some of my electives. But now, since it's bumped down to 3 level, I expect everybody to complete that first because you cannot take microprocessor along with your embedded system, right? You cannot take microprocessor with advanced microprocessors. So that creates a big kind of conflict. So I really recommend that students to finish microprocessors before hitting any of the major electives. And if possible, I don't know if it fits at all, the end of 4th, if you can fit into 4th semester, that will be best, but at least 5th, because if you move the microprocessing into the 6th semester, you're bumping everything out and you may not be able to graduate with confidence at the end of 8th semester. One thing I want to say, this again, for both majors, is that it's really what you know that your job, not what you actually put on resumes. This actually, sorry, I resonate to one of the things. I kind of know a lot of programming languages, but do I put in there? I'll say yes and no, because, well, I've seen interviews running like this, and student put in C++ on the resume, and he really hasn't used that C++ for a couple of years, right? Right before the interview, I asked him, okay, you review these, and you guess what? At the end, he said, well, the interview, because now it's Zoom, older days, it might be like phone calls and stuff, but right now they just share screen. And on the screen, you see problem for programming, you're actually supposed to type in code. It will run on the server over there, tell you if it's wrong or correct or wrong. So it's really hard to hide the things they barely know. So how do you do that? One is try not to, take things off if you actually know a little bit. But over the time, especially when the first time you actually approach that language, try to get to a good level. Okay, not just because you did say a senior project, you just install this Python package, then you run something, and magically, even you can run AI applications in about a day or 2. So OpenCV allows you to do really decent things with a few strokes. But I really recommend you to go beyond that. That means if you're interested in this, search for some good website tutorials about the best, say, Python writing style, and get a very thin book. Now the book's only like $20, $30, gives you a really, really good, say, efficient Python programming. So read all these in depth, although your, say, project only requires this little, but you want to go more. And for every single thing, for example, you take my course, I teach a special language called Verilog. be deep, be expert, just absorb everything that you were taught in class. So that's the way that you can be successful in the future, because now, believe it or not, they have so many different ways to test your skill on the spot. Okay, so that's this. And if you don't have a question about flow charts, and hopefully everybody following those. And most importantly, hopefully most of the students are showing up as rising junior. Sometimes students delay the signing of the degree plan until the last semester of the junior year. Then they try squeezing so many different courses into 2 semesters. It's very hard to arrange. So basically, you want to plan for the next 2 years, then instead of trying to squeeze everything in the last year. Okay. So in terms of courses, for CP, since you have less choices, again, these are the best choices for both degree plans. And the top 3, although you see these dotted lines, the Micro P and my Advanced Digital Design course is co-requisites, but these are more historical. We need to tell the department to change. Basically, you just think about you have to finish all 3 top courses to really confidently move down to the courses below. Because although I don't necessarily need the assembly code from Micro P, but the concept of seeing a sort of computer architecture, how things run, will really help you to develop your thinking skills in my course. So just think about, you really have to take care of the top level 3 courses before you hit the last 3. And hopefully you leave at least 3 semesters for 3, because although it's 2 out of 3, but each course is only taught once per semester. Oh, it's actually taught once per year. And if you have some notes, take notes. The first one, embedded systems, is only taught in fall. So if you want to graduate in May and you kind of miss the fall semester, suddenly say, oh, I want to take this course in the last semester. No, there's no chance. So make sure going to CP, the time plan is the essence. You have to plan 1.5 years ahead, knowing what you're going to do for each particular semester. And the second one, you can see 2 different course titles with associated with the same course number. Older days, it's called Advanced Micro P. So it's 1 step up. But since lots of students, honest or not, they're kind of scared after they took the Micro P. So the Advanced Micro P doesn't have the appeal that much to students. But honestly, that course is teaching every single cutting edge technology associated with embedded systems. So we renamed this to Intro to IoT, which is Internet of Things, which is hottest topic in the industry, and RTOS, which is real-time operating system. You need those to deal with real-time sensing and control of all the machineries and drones and robots. And this course, depending on the catalog you're seeing, you can actually, I think it's still in the transition, so just double check, either it's called Advanced Microprocessor Systems or it's called IoT and RTOS. Again, this is a great course to take for both embedded systems and for computer engineering students. Okay, both the first 2 courses are embedded C based. That means you're gonna learn, you're gonna get some microprocessor boards, and the instructor will teach you how to program those to maybe do a robot cars or robots, or depending on which semester you're working with. And those are also highly sought skills, because you see the oil gas companies, when they run down those sensors, they have tons of processors in there. And Tesla and whatever the cars, they have hundreds of processors on board. Okay, but these 2 are on the same trend. That means they reinforce on each other on the embedded system programming. Okay, and so the first one is in the fall and the second one is in spring. Okay, now it comes to my class. Okay, this is a different type of class. I teach brand new language called Verilog HDL. So those are the languages called hardware description language. So you use software concepts, but design hardware and actual digital circuits. And the same method can be used to design Intel's processors. So again, so if you want to work for, say, Intel, AMD, or those companies, and you want to design their chips, this is the route that you want to take. and also lots of FPGA designs in my course. And FPGA is becoming more and more powerful. So lots of companies using FPGAs directly as the end product. So people also hire for that. But you really have to be ready for this course. Usually I tell the things that you should not, say maybe 10 reasons you should not come into class. You can actually evaluate your traits and your working style and your desire to decide, because if you are not fitting for this class, you'll feel badly. But if you are the right type, this one will let you excel. So it's kind of bipolar type, and it's not yes or not wrong. It's not you feel you're not doing well or you're not capable, but just if it's kind of a little bit different type of people. So I'll tell a little bit. And in terms of the scheduling of the courses, and you're going to sign up for this degree plan, right? And degree plan is almost like not complete contract, because my course has a kind of request or wait list. And usually I take maybe 50% of people off the wait list. And then there are people who will not get in. But for CP students who are actually advised either through the advising week or by email exchange, I'll give them more details. And sometimes I do run the Zoom sessions to really figure out if the student is fitting for my course or not. If you pass all these kind of checkpoints, then I'll assign your degree plan with this course as a choice. Then at the same time, I'm going to send you a link that I create this link on Teams. It's called the Degree Plan Information Form for my Advanced Digital Design. That means you're on this priority list, because every semester between 30% to 50% will be declined because there's no room for them. So these things are, I already talk about the course numbers, and I make these all prerequisites, at least on my book. In the catalog, some of me call requisites, but I don't think that's a good choice. And as you can see, the coverage, the embedded system will more, again, works on real-time embedded system. They have a project-based class, and the instructor to teach both the first two courses is the one who's been working with Compaq and HP for over 30 years. He recently retired from HP, so we recruited him to teach us on this. So he knows almost everything. So it's really, really great. It was Dr. Harry Lay, and I haven't taken his classes, and he knows everything. He works so closely with students. You can just ask questions. Now it's through Zoom, but in a regular classroom setting, you can just go to his office, ask questions. So you can learn a lot by taking the top two courses. Yeah, I'll talk a little bit about my course. Again, my course will teach Verilog HD. I haven't heard about that. That's a special language. And again, not only that, it's a special language for hardware, but also the course will change your thinking a little bit. So some algorithm, it seems to be fine in computer science, will not work in my FPGA. So I actually say this works in your C program, but if you run this one on my FPGA, you'll feel badly. And the course will be using a FPGA board that you will purchase. Actually, it's like $100 plus shipping. And so everybody will have their own boards. This one was starting this spring semester. So everybody needs to purchase those little boards. And again, it's shipped from Taiwan. So to reduce the international shipping fee, in October, I'll actually get the permission forms out. The ones who get admitted will send a purchasing link that Taiwan vendor set especially for UH. That means by a deadline, usually maybe December 1st, they will get everything that from that purchasing list. They'll do one shipment to UH. So we end up so this past semester, every student paid $5 for shipping. But if you order directly, the shipping fee for that board alone is between $35 to $50. Just get that from Taiwan. So make sure that if you're taking this course, you don't miss all these kind of checkpoints. Now it comes back to the form. All the forms will go back to me. And number one, I kind of figure out in kind of different ways. Students told me that Miss Amanda asked you to upload the forms into Teams, right? That's after you get signature from me. Okay, and students, they actually told me that they saw the forms that was sitting there thinking that I have access to the form and can sign off on it. No, that didn't happen. So you have to email me the form and I'll have maybe some discussions. You can also tell me if you've been to advising week or not, then I'll sign it. Once I sign it, again, I don't collect forms. So some student asked me, is the signature, that's all I need? No, you have to submit that to the department, whatever Miss Amanda tell you, you have to submit. Okay, I sign, but I don't keep any forms. So that's kind of the logistics, but that's something I learned from my students, saying students just upload unsigned forms there, which I don't even be part of the team, and thinking I'll go there and sign off on these. Okay, so now coming back to the final choice, which one you should pick, which two you should pick. Again, I think first is really think about your career goal. Okay, if you pretty much knowing that you would do lots of embedded and you love to work with Raspberry Pis and all the new devices, and embedded C really attracts you, I think you will not go around stick with 2 additional courses above micro P, because I think 1 is not sufficient. So 2 will really get to the point where you can be really, really competitive. But then there's different type of people. They say, okay, some people say, I like verification jobs because there are lots of opening on verification jobs. And some people say, okay, future, I want to design my own chips, be FPGA or be ASIC. Then you might want to consider my course. And one thing that you need to consider is that for my course, the only reason you should get in my course is that you are determined to want to get an A. Okay, to me, there's no B student, not to say C student or D student, that didn't exist, literally, except for a few kind of cases with personal reasons. But if you don't have a mindset that I want to get an A, please don't come to my course, because I run 2-week major labs. Every 2 weeks, we'll have a major FPGA lab. That means there's no download of any software. Okay, I give you a board, and the board does nothing but getting the power. Okay, so everything you do, you have to know exactly how it works in your mind first, then teach FPGA to do it. So it's doable, and I see students be successful on it, but students are expected to spend quite some time outside the 3-hour lecture window, because debugging is art, right? So you can have one bug, it takes you 3 days to find it, right? But we do help, like in the past, like 20 days, I probably help about 20 students, especially on the harder lab. I actually look at their code to give them advice and so on. But you have to prepare that you want to spend extra time outside the classroom time to get the board working. And the other thing is that, so it's 2-week major labs, and each one is built onto the previous lab. So there's no way to skip any labs. For example, you build 3 components on lab 1, then you actually build new component on top of lab 1, and lab 3 is built on the working lab 2. So if your lab 2 doesn't work, your lab 3 will not be working. And also the lab 4 as well. And we basically, in the lab description, we say we are only grading labs once it's working. So I do give, so by due date, students ask, how can I ensure that it's working? Again, I don't want any student to cut corners. So no, students are working diligently, but on the due date, if you don't have a working system, you're going to submit to a need help link. So we have a need help submission link, and then you can upload a cover letter and also write an email to me saying, this is what I have been so far, and this is the bug I'm facing, and I'm going to go from there. So based on what I see, and I'll give them advice. Sometimes I ask them to send me code and stuff like that. But you can see that lots of interaction outside the classroom time, and also lots of dedications on the student side. So there's no skipping, and there's no cut corner stuff. So literally, I told everybody that students in my class don't cheat, because they know how important it is, and students, they'll just stuck with the bug, right? They'll stick with that, and overnight in 2 days, they say, okay, Dr. Chen, can I get your help? And sometimes they want to work hard enough before they approach me, and some students just approach me when they say bug. Both are fine. But as you can see, I help every student get the lab working through lab 4. Then they'll have a 4-week final project. okay? And we have required features that's built on top of the 4 working labs. So there's no skipping at all. So either you be successful or you fail really badly. And I don't want that to happen. So if you are not those type of people, please don't even put on the request on the wait list, because every year we have about 50 people who can come into the class. But I really want to see what kind of things that fits your lifestyle better. And if you are really motivated from within, because this only happens from within. So if you have a drive, say, I want to take this challenge. I want, no matter how hard it is, I want to fix that bug, get the board working. And of course you get joy after that. So if you're these type of people, then this is probably the course that you want to consider. There's no, what labs are easy. I always say labs are easy unless you see a bug. And bug as defined, I just kind of joke with my current student, bug is so small. That's why it's called a bug. So sometimes students send me the code, I cannot see it. So it was so tiny. So they're really approaching excellence, but since it's a bug, it's not working at all. And if it's so obvious, it's not called bug anymore, it's called error, right? So those are things that I want you to consider, and I really have to control my timing. So that's my last slide. Again, if you have no doubts and then you can send me your choices. You just do 2 check marks out of 3. If you have questions, you can email me first about your questions, and we'll see if you want to do face-to-face or by email. Then once you settle down, I'll sign off on your form and then you will submit. All right, okay, I always talk longer than my allotted time. Okay, any questions?
I have one. Do computer science electives count towards anything with the computer engineering degree?
I don't think so, because if you look at the form, everything else is pretty much set in the chart, right? So all these are ECE elective with ECE lab. So you can take additional credits as enrichment, but I don't think it will count to any of these core electives. And you cannot do replacement unless it goes to the committee thinking they're equivalent, but it's pretty hard.
Okay, thank you.
Question about the wait list. So if we don't make the wait list, then I'm guessing, do you have to wait for the next year, or do you just go to the computer embedded?
Depending on which year you are graduating. So if your request, say the fall semester in your junior year, say I wish to be taking a class in your junior spring semester, and again, we usually have a higher priority to seniors, and we take a subset of juniors. So hopefully some of them can become my future TAs, because if I only take senior, I don't have TAs anymore for the following year. So some juniors might get in my course, but not all of them. So most of the students got in my course eventually in senior. And there's one student in this class saying, okay, all my undergrad years, I requested course, didn't get in, now I'm in graduate school, can I get in? I say, of course you get in. So people waiting like 2 to 3 years to get in the class. Yeah. But otherwise, so once you put on the wait list, you are a little bit higher priority in the next year, especially if you actually assign your degree plan and also you request in junior year, then pretty much I try to guarantee that those students, by the time they hit their senior year, they can get into class.
Okay, thank you.
No problem. Any other questions?
I had a question. I don't know if it's exactly pertaining to the CPE, but like I was looking like on like the CPE flowchart. There's like a box that just says like elective. Is that like another ECE elective or a CPE elective, or is that just like any elective or something?
I think that's this one, right? You see this form, right?
Yeah.
You're supposed to select one EC elective with a lab. That means the second digit of your course number has to be a 4. So for example, all 3 courses have a lab, and these already count towards the ABED required lab courses, but you still need one additional one. So like people like to do machine learning, but machine learning, as far as you know, is only 3 credit course, doesn't have a lab. You have to take something like into networking. So the second digit you see on course number is a 4. That will meet the requirements for the EC, unless you actually take a 1 credit lab on top of whatever you take. Okay, did I answer your question?
Kind of. I
Oh,
think I don't know. I was just looking at the flowchart. There's like I see there's like CPE elective, ECE elective, and then there's
yeah.
like a box that says elective.
Where's the elective? I
Uh,
don't see it.
I don't know. I look at like the 2019.
I think that's out of date. This is I use this chart for fall 2020.
Oh,
So
okay.
you only have 3 slots. So 2 out of 3 for the CP elective, right? That's where your choice will go. And also EC elective with the lab.
Oh, okay.
Yeah, I've seen actually, even for the embedded, I've seen students downloading some old forms, which don't even have the new advanced micro P in there. But in terms of signing off this form, yeah, you have to kind of decide if you want to stay with software side or you want to branch off. Again, branch off has a little bit kind of cost into it because it's brand new. You have to do a little bit risk taker type and being open your mind. And you will need, if you decide to jump in, I don't need a textbook. You basically learn everything through my lectures, and you don't even need to Google anything. So I taught a whole package, okay, without relying almost on any of the external sources. The only thing that eventually at the end of the semester was the one FPGA tutorial from Intel. But I taught everything, and students don't need to search for any external resource to know exactly what it's needed, and they will do a final project on that. But for embedded, it's more resource on website, and for projects, you probably want to search for, say, how to run Python, all those things. The professor is not necessarily teaching everything, but of course, you have a larger, broader base for potential opening. There are less, honestly, there's less digital openings than the embedded. So that's kind of a scenario. But I think for both, all these courses, especially if you want to decide to go to CP or embedded, you want to be passionate about what you're doing, because whatever you do, you are able to create. You are able to create new products, getting new features, get into people's hands, get into medical devices. So it's really exciting. But one thing I just kind of I don't know, most of the people here has pretty good programming skills, I guess. But people who will not be very successful despite their desire is that if you find any program is really hard for you. So one time I hired that was my first PhD student I hired. It was fantastic on the resume, but once the person arrived, I said, Dr. Chen, I can write a program with less than 50 lines. Okay, that will not fly in any of these majors. Okay, so if you're only comfortable with MATLAB code, they're really, really short, right? And there are lots of actual packages behind it to call for, so you don't have to worry about those. So if your mindset is more towards that, I'll really advise you not to be staying away from CP or embedded. I think once you go to junior, senior years, to my view is you're gonna play with your strength. You can challenge yourself. You have to, don't just bet on the weakest point of your entire kind of skill set. Okay, there's people who transform, but if you're really bad in terms of getting your long thoughts into algorithms, things, it will be really hard to get the best out of the embedded or computer engineering programs, because people assume that you can program. That's a default skill, any programs. And even you come to my class, one year I got a student who never took any C program. It was really, really hard semester for the person. But so we actually use software syntax to design hardware. So that's my advice. Again, just give you a honest evaluation. And there's nothing wrong. There are people who are doing power, who are doing like control, and they don't need to touch any piece of code. They're doing really, really well. And nano as well. So just give you a fair judgment, which one fits your life goal the best. Okay, any other questions? You can always just approach me, and my email is the beginning. Yeah, just email me anytime, okay? And again, before you sign off, if you need to actually talk more, I can set a Zoom with you. Okay, write down this again. My email is also on my faculty website. All right. I think.
All right. Well, thank you very much for coming out, Dr. Chen.
All right, no problem. Sorry for delaying. Next time I need to put the clock in front of my computer. Okay, but
all good.
I hope that everybody here learning something out of my talk. All right. Okay, thank you for inviting me.
Yes, ma'am.
Okay, bye.
All right. So for our students, that concludes today. So thank you guys for coming out.